Okay, so hopefully by now you've had a chance to go over that lesson on integer exponents and do all the practice associated with it. It takes a lot of getting used to working with all the different rules, and especially when the exponents were negative. We're going to look at other types of exponents that may be a little bit new to you. But before we get into that, I just want you to consider, let's say we have 2 to the exponent of half times 2 to the exponent of half. And I want to take a look at this two different ways. So first off, let's take a look at it in terms of a product law. So right now we have two powers with the same base of 2, and the way we deal with the exponents is we would add them together. So this is the same thing as 2 to the 1/2 plus 1/2. Okay, so again, just adding the exponents there. And when you add a half and a half, you get 1. So this is 2 to the 1, which is just equal to 2. Okay? Take an alternative approach to it. This is the same thing as 2 to the half times itself. So this is the same thing as 2 to the 1/2 all squared. Okay, so taking that approach, a half times 2 is 1, so you get 2 to the 1, which is equal to 2. Okay, so now we've established that you can do this in two different ways, and that in both cases the answer is 2. Remember that another way of writing 2 is saying that it's the square root of 2 all squared. Okay, much like the square root of 9 all squared. Well, the square root of 9 gives you 3, and 3 squared is 9. Okay, so square root of 9 all squared is 9. Square root of 2 all squared is equal to 2. Basically, that squaring undoes the square root. You just let what was under the square root to begin with. Okay, so again, remember, using this, so it seems kind of silly that we've just written 2 as a square root of 2 all squared, but remember, this originally came from having 2 to the 1/2 all squared. So if 2 to the 1/2 all squared is the same thing as root 2 all squared, what we can actually conclude is that root 2 is the same thing as 2 to the exponent of 1/2. Okay, so it kind of seems weird that you have an exponent that's a fraction, all of a sudden it means the same thing as a square root, but that is what's happening here. So square root of 2 is equal to 2 to the 1/2. Okay, now let's see what would happen if we tried something similar with 2 to the 1/3 times 2 to the 1/3 times 2 to the 1/3. Okay, so using our power of a power rule, this would be the same thing as, so this is 2 to the exponent 1/3 multiplied by itself. There's 3 of them. So this is the same thing as 2 to the 1/3, all to the exponent of 3. Okay, so what we would then do here is multiply the exponents. 3 times a third gives me 1. So the same thing as 2 to the exponent 1, which is equal to 2. Okay, well, another way of writing 2, I don't know if you've dealt much with cube roots before, but the cube root of 2 all cubed is also equal to 2. Okay, and just before I get too much further, just remind yourself what cube root means. Let's say we're to take the cube root of 27. Okay, I'd be looking for, basically what I'm looking for is that there's some number that when you put it to the exponent 3 is equal to 27. Okay, and the cube root of 27 is the solution of this equation. So if you're going to see your calculator, you're going to see that the answer is going to be equal to 3, because 3 to the exponent 3 equals 27. Okay, so again, if I were to take both of these sides to the power 3, well, the power of 3, the exponent of 3 undoes the cube root, so all that's left here is 27, and 3 out is, again, 27. Okay, so the cube root of 2 all cubed is equal to 2. Okay, and we can make another conclusion here, because this is the same thing as this. The cube root of 2 all cubed is the same thing as 2 to the 1/3 all cubed, that 2 to the exponent of 1 over 3 equals the cube root of 2. Okay, and if you're not sure how to evaluate cube roots on your calculator may have a specific cube root button that would look something like this. Okay, it also might have a general root button which has an X with a root, and this one's going to be very, very handy because it doesn't just do cube roots, it will do eventually 4th roots, 5th roots, 6th roots, and so on and so forth. So the way you would work with that one, let's say I asked you to do the 4th root of 81. Okay, well, what you would type on most calculators is you type 4, and then that X with the root button, and then 81, and that would give you your answer, which should be 3. So give that a try. Again, it's always good to know how your calculator works. If it's not working out, let me know, and I'll show you how to go through that one. Okay, so again, we've made a couple of conclusions here, that 2 to the exponent of 1 over 3 is equal to cube root of 2. And over here we said that 2 to the exponent of 1 half was equal to square root of 2. Okay, so a little bit of a pattern that you've seen so far is that when you have a fractional exponent, that the denominator here seems to have something to do with the root that's involved. So again, here you see I had a denominator of 3 in our exponent here became that root. Okay, so how can we express that in a different way using radicals? Well, in general, we can say that if you have any value x, the exponent of 1 over n, it's the same thing as the nth root of x. So this would be the same way as same thing as saying that. Let's try 25 to the exponent of 1 half will be equal to the same thing as the square root of 25. Okay, the 32 to the exponent of 1 over 5 will be equal to the fifth root of 32. Okay, so you have a bit of a connection there, right? If you're wondering what a fractional exponent means, it means a certain type of root that you can do. Okay, and again, the pattern that you're seeing here is that the denominator of that fraction becomes the type of root that you take. Okay, so again, denominator of 5 means fifth root, denominator of 2 here means square root. Now, as a rule, square root is the basic root that we've been using all along, so you don't need to write a 2 here. Okay, it's completely not necessary, so if you do, that would be a communication that's just not included. But any other root, you have to write in the number there. Okay, so take a little bit of a step further. Let's say we had the nth root of something, but that something had an exponent on it. Well, this would be the exact same thing as writing x to the exponent of m over n. Okay, and the reason for that is, let's just say, again, I use this first definition up here and say that the nth root here means I have the exponent of 1 over n. So what this would mean over here, so this would be the same thing as x to the exponent m, and all of that would be the exponent of 1 over n. Okay, well, the power of a power rule tells me that this would be the same thing as x to the exponent of m times 1 over n. And we all know when we multiply those two fractions together, the m would multiply in the numerator, so we would get m over n. So that's where that rule comes from. Okay, and similar, since the order of multiplication doesn't matter, we could say it's the same thing as x to the 1 over n all to the power m. Okay, so the order in which you apply those exponents doesn't actually matter. And again, you get a couple different expressions here. So what this actually means now, and again, just to put it in terms of concrete examples that you can work with, let's just say you had 9 to the exponent of 3 over 2. Okay, well, okay, using the fact that we know from rule number 9 up here that the denominator of the exponent tells you the root that you have, this would mean we'd have the square root of 9. And it would be the square root of 9 cubed. Okay, so we'd have to figure out what 9 cubed is and then take the square root of it. Alternatively, what might be a little bit easier, since again the order that you apply these exponents doesn't matter, you can do the square root of 9 first, and then apply the exponent 3 to it. Both of these are accurate, both of them will work, it's just a matter of what you find easier. Okay, you're going to get probably doing a lot of work without calculators throughout this unit, so it's definitely worth trying to simplify your work as much as possible. So on a calculator, it's so much without a calculator, it's so much easier to do the square root of 9, because you know that's equal to 3, and then taking 3 to the exponent 3, then all of a sudden trying to figure out what 9 to the power 3 is, and then trying to take the square root of that. Again, they'll both work, but again, one is easier than the other. So to give you another example, let's say we had, okay, let's say 125 to the exponent of 4 over 3. Okay, and again, this is something you could evaluate in your calculator so you have an idea of what the answer is. But again, what this actually means is that you'd have the cube root of 125, and all that would be the exponent of 4. And again, you could have 125 to the exponent of 4. That's a much larger number to work with. You could work with the cube root of 125 first. Writing that through your calculator should tell you that that's equal to 5. So you have 5 to the exponent 4, which is 625. Okay, so these are again some new exponent laws to work with. So essentially now when you have an exponent that has a fraction, you know how to evaluate it. Okay, so let's do some practice here. We're going to start by taking something that's in what we call radical form, okay, because there's roots involved, and express it with rational exponents. By rational exponents, I mean the exponents have fractions in it. So just as a note for yourself, remind yourself this is radical form. Okay, and we want to express it with rational exponents. So in this case, I'll do the first one with you here. We have the fifth root of x. The fifth root of x, by definition, means that it's x to the exponent of 1 over 5. Okay, okay, so I'd like you to try B and C on your own. Okay, and just try and make those quick conversions to having something x to the exponent of some fraction, so something rational. And when you've given them a try, it shouldn't take too long. Push play, and we'll go through the answers together. Okay, here are the answers for B and C. So just to recap here, when you're looking at B, we have the cube root here, and again, the type of root becomes the denominator of the exponent, so it's x to the something over 3. Well, again, and that something is the exponent that's on x under there. So again, remind yourself this would be actually the same thing as the cube root of x, okay, all to the exponent 7. So that helps you visualize it in a different way, then feel free to do so. Because again, cube root of x is x to the power of 1 over 3, and that's all to the power of 7, and 7 times 1 over 3 is 7 over 3. Okay, so again, that's that one in with rational exponents. Okay, for C, it's the same idea. So we have the sixth root, so that becomes the denominator of the exponent. X is to the power of negative 2, so that becomes the numerator of the exponent. Now, one thing you'll notice here once you put this together is that 2 and 6 will reduce. So this reduces down to x to the exponent of negative 1 over 3. Now, as a rule, even if it's not explicitly stated, you should have your answer written with positive exponents, just because it looks cleaner. So, referring back to last lesson, how you deal with a negative exponent. Well, we can make it a positive exponent if we take the reciprocal of the base. So instead of x, it's going to be 1 over x. So then it'll be x to the exponent of 1 over 3, positive 1 over 3. Okay, so with 2, again, now we're just looking, we have a case with actual numbers in this, we can evaluate them. And I know that this could be something you could, in theory, run through your calculator. I do not want you using a calculator for this as much as you possibly can. I want you to convert it to radical form first. We know the forms, we know how to convert between the two forms, and how to then evaluate it again. Let's say if we didn't have a calculator. So again, I'll do the first one with you. So let's say you have 16 to the exponent of 1 over 4. Again, running it through calculator will tell you the answer, but we're trying not to do that. So this is going to be the same thing as the fourth root of 16. Okay, so you need to ask yourself, okay, the fourth root of 16 would be the solution to the equation something to the exponent 4 equals 16. Okay, so what's that something going to be? That's going to be 2. Okay, and by now you should be starting to recognize some of the main powers of 2, 3, 4, and 5. I gave you a list of powers you should be able to recognize in the last lesson, just because they become a lot easier to work with, especially when you don't have a calculator handy. Okay, so in this case, the fourth root of 16 is equal to 2. Okay, I'd like you to try B, C, and D, and a couple things to watch out for here. Here you have negative exponents, so I would suggest converting that to something with a positive exponent first before trying to evaluate it. And once you've gone through those, push play and we'll go through the answers together. Okay, so take a minute and check your answers here. So for the first one, what I did, for the first one, I mean B, what I did is I first dealt with a negative exponent. I moved it down to the denominator so it became a positive exponent, just to make it a little bit easier to deal with. And then I converted the power to radical form. So it's the exponent of 2 over 3, so 3 becomes the root, so it's the cube root of negative 27, and then all that's going to be squared. Okay, so the cube root of negative 27 is negative 3, because negative 3 to the exponent 3 is equal to negative 27. Okay, it might seem a little bit weird because you're used to not being able to take negative roots of things, but that's only if it's an even root, right? The square root of a negative number doesn't exist because something squared or even something to any even power, something to the exponent 4 or 6 or 8 or so on and so forth, that always has to be positive. So an even root of a negative number doesn't exist, but an odd root can exist because it can be negative. So the cube root of negative 27 is negative 3. That's all squared, and that gives you 1 over 9. Okay, I'll finish going through over C and D in part 2 of the lesson, and we'll see you over there and continue on.